I'm Anil Kumar, and in this video we'll discuss the terminology which is used for polynomials. The first term to understand is term itself. The definition is given right here. Term. It is a mathematical expression using numerals or variables or both to indicate a product or a quotient. So it's kind of like this. When we say combination of numerals and variables, these numbers are numerals like 7 and all, right? Variables you could write like a, x, y. These are the variables. Now when we write them together, it is kind of multiplication, right? So that is the product, right? We could have quotient. That means we could write 7 over 3, right? That is it. We could also write the variables in the denominator. Since we are discussing polynomials, I am avoiding to write the variable part of the terms in the denominator, right? But when we are talking about algebraic terms, we could write them in the denominator also. Now these variables could have exponents which are kind of like this, right? We could write like that. So that forms one term, correct? So that is how you should look at a term. So let's get back to the definition. It is a mathematical expression using numerals or variables or both to indicate a product or a quotient, right? So that is how we define a term. A term has numerical and literal coefficients. Now in this particular term, we have a numerical coefficient, which is the number 7 over 3, right? And we also have a literal coefficient, which constitutes these variables, which are a square x y to the power of 4. A term without literal coefficient is called a constant. So if I give you an example of, let us say, minus 5. Now this minus 5 on itself is also a term. It does not have any literal coefficient and therefore it will be treated as a constant term, right? So you could have 3 over 2 likewise, right? The degree of a term is sum of the exponents of the literal coefficients. Let us check the degree of the term in our example. A square x y to the power of 4. These are the literal coefficients, and degree you have to count them all. So the degree here is, see, 2, if nothing is written that means 1. So the degree of the particular term is 2 plus 1 plus 4, and that is 3 plus 4 is 7. So that is the sum of the exponents of the literal term. So that is our term. These are the exponents, 2, 1 and 4. Add them to get the degree of the term. Several terms added or subtracted form an expression. So expression would be combination of such terms. So let me give you one expression here. If there is only one term, it could be called as a monomial. We'll get to that. But we could have something like this, 2x squared minus 3xy. So this is an expression which has two terms, right? If I add some more, let us say we write y cubed, then this one has 3 terms in the expression. So we have terms which are added or subtracted, right? Then we have expressions are classified in terms of number of terms: monomial, binomial, trinomial. Monomial, as the name suggests, means one term. For example, we could have 7x. Binomial will be like two terms. For example, we have x squared minus y. So there are two terms, right? You could write a constant also with one of them or both of them. Trinomial will be 3 terms as given here. So we could give an example of trinomial as 4x squared minus 3xy plus y squared, right? So there are 3 different terms. It becomes a trinomial. Now, Degree of the expression is the largest sum of exponents of all variables in one term. So to find the degree of an expression, which is kind of like this, combination of terms, you have to check the term with the highest degree, and that becomes the degree of the expression. So we'll take up an example to calculate the degree and to name the expressions in another video. Now the last point here is polynomial expressions will have literal terms with non-negative exponents only. So any term which has only non-negative exponents, that is to say, it could have exponents as a whole number, 0, 1, 2, 3, 4, likewise. Those terms combine to form polynomials. So polynomial expressions will have literal terms with non-negative exponents only. For example, if I write 2 over x, or if I write 3x to the power of minus 1, these are not polynomials. Do you understand? These are not polynomials since we have x to the power of minus 1 negative exponents, right? Not polynomials. But the examples which we have taken here are all of polynomials, right? So that is how we can understand few terms regarding the polynomials, which we'll discuss further. I'm Anil Kumar, and I hope this helps you to bring together all the terms of our interest. Thank you, and all the best.